This is section 2.2, inverse variation. Inverse variation occurs when y varies inversely as x to the power of n. That means that this time, x and its exponent are going to be in the denominator. Let's do some examples of that. In a given room with the floor space f varies inversely as the square of the number of people in the room. Write the equation to express this situation. I'm going to translate from English into this equation. I see f varies inversely as the square of the number. So I'm going to say f varies inversely. That means that my x is going to be in the denominator. And this time I'll call number n. And it's the square of n. So now I can see my floor space varies inversely, my variables in the denominator, to the square of the number of people in the room. Let's try number 2. Time t required to do a job varies inversely as the number of workers W. Let's first write that equation. And I'm going to go ahead and erase this and pull this up. Time t required to do the job varies inversely as the number of workers. Time varies inversely, and I'm not given any power of W, so I'm done. Now it tells me if it takes 5 hours, that'd be my time, for 8 cement finishers, that'd be my workers, to do a job, and it asks me a question, how long would it take 12 workers to do the same job? So first, before I can solve anything, I need to find K. So I'm going to plug in 5 for time and 8 for W. To solve for K, I multiply both sides by 8, and I end up with a K value of 40. Now that I have my K value, I can rewrite my inverse variation equation, and I can solve for something. Now it asks how long would it take 12 workers to do the same job. Hopefully you agree I'm solving for time and I know W. So I'm going to plug in time equals 40 divided by 12. And let's go ahead and give this in decimal form. And I get 3.333 hours. Or if you wanted to write it in exact form, 3 1/3 hours. All right, the intensity of light in number 3 that reaches you from a light bulb varies inversely as the square of your distance from the bulb. I'd like you to go ahead and try to write the equation that matches that sentence. Intensity varies inversely as the square of my distance. Hopefully we agree with our equations. When you're standing 10 feet away, intensity is 130 units. That is going to allow me to solve for K. So if I have intensity is 130, I don't know K yet, and my distance is 10. Now I can solve for K. I'm going to get 130 equals K over 100. And when I multiply both sides by 100, I am going to get 130,000 equals K. Now I want to know what's the intensity of the bulb when I'm simply standing 4 feet away. So I'm going to rewrite my equation with my value of K. And now I can see that I equals 130,000 divided by D squared. I'm given a value for D, and I'll be solving for I. When I simplify, hopefully we agree that 4 squared is 16. And then we are going to divide 130,000 by 16. So first, let's go ahead and simplify this. 4 squared is 16. And then we simplify, and I get 8,125 and Not really given any units in this question, so I'll call, units. We'll just call it units. All right, for tomorrow, on a separate sheet of paper, I would like you to answer these 6 questions for me. The first 2 things we've done this week are direct variation and inverse variation. And I'd like to know for each of these equations, whether it's direct variation or inverse variation or neither. I'll see you tomorrow.